Welcome back with a new video on circles. As we know what circles are a closed figure which has points which are equidistant from a fixed point in the same plane. This fixed point is known as center. This fixed point is known as center, and the equidistance from the center to the boundary is known as radius, and one complete segment from one point of the boundary to the other is completely known as diameter. So diameter is the longest distance in a circle. If you have a segment which is not crossing the circle, if you have a segment which is not passing through the center, then it is known as chord. So a chord is a segment which is on the boundaries of the circle, but they do not cross from the center. If a segment crosses from the center from one point to the other point on the circle, then it is known as diameter, and a segment from the center to the boundary of a circle is known as radius. It is a part of a circumference. This is known as arc. So if I have a point P and B, so we have arc A P B. A B is my radius, A Q is diameter, and AX is chord. Apart from this, we have sector. Let me erase this. I have radius and an arc. So the area between this is known as sector. Okay, so here if I have AOB, so sector AOB means this area. Then this is my segment, which is a chord. Now if a chord divides the circle into two parts, then the one which is a smaller part is known as minor segment, and the bigger part of the circle is known as major segment. Let's start with our circle theorems. The first theorem: the angle that an arc of a circle subtends at the center is double the angle which it subtends at any point on the remaining part of the circle. So over here, as it says, an angle that an arc of a circle subtends at the center means the arc which is having an angle which is at the center doubles the angle which it subtends at any point on the remaining part of the circle. So any angle that we have over here. So here what it means is, if there is an arc which has an angle from the center and an angle that is on any part of the circle, okay, then at that time, if this is x, then this is 2x. This angle that is on the center will be double of the angle that is on the circle. So over here the important part is that both the angles should have a common arc. So here they need to have a common arc, and one of the angles has to be at the center, one angle has to be on center, and the other angle should be on the circumference of the circle. Getting it? So if this is x degrees, then this is going to be 2x degrees. So our first condition, common arc, center on the circumference. So if this is x, this is going to be 2x. Similarly over here, don't panic after looking at this diagram. Over here in this diagram, now we see over here this angle. Okay, we'll concentrate on this angle. Has an arc. This is its arc. Then there's another angle over here. This angle also has the same arc. That means they both have same arc. So therefore, if this is x, this is going to be 2x. So if this is, say, 120 degrees, then this is going to be 240 degrees. Similarly over here, one angle is from the center, the other angle is on the circumference, and they both share same arc. Therefore, if this is x, this is going to be 2x. So remember, when you're talking about theorem 1, always search for angles which have the same arc. When they have same arc, search for the angles. One angle has to be at the center and the other angle has to be on the circumference of the circle. If this is so, then the angle that is over here, if it is x, then the angle that is in the center is going to be 2x. Very simple to remember. Just be careful. First thing what you're going to do is search for a common arc and then see where the angles are situated. Now the second theorem is also known as same segment theorem. Here there are angles in the same segment of a circle are equal. You may also say that the angles that are on the circumference which are having a same arc are equal. So when an arc has two angles which are on the circumference, then these two angles are equal. So if this is 45 degrees, this is also 45 degrees. We saw in theorem 1, if the angle is in the center and the other one is on the circumference, then the one which is in the circle is on the center is double the angle that is on the circumference. Here both are equal, both angles that are on the circumference are equal if they have a common arc. Now here it becomes a bit tricky how to find out. So just do one thing, find an angle that is on the circumference and just have a glance of those angles which are on the circumference having the same arc. Once you find out, you can easily say that these two angles are equal. Theorem 3 is a special case of the angle that is at the center theorem. It states that the angles in a semicircle is a right angle. If you have a diameter, then the angle opposite to it is always going to be 90 degree, provided the angle is on the circumference. So in a circle there is a diameter and it forms an angle on the circumference, then the angle is 90 degree. So over here the conditions is you need to have a diameter and the angle that is being formed has to be 90 degree. That has to be on the circumference. Okay, got it? So a chord won't do. It has to be a diameter, then only you will be able to say that the angle that is on the circumference is 90 degree. So when you are writing statement, you can write the angle in the semicircle is 90 degree. Over here they could make it tricky. Rather than giving just a semicircle, they may give you a complete circle and you may need to find it. So when you're doing so, search for a diameter and check whether the diameter is forming any angle that is on the circumference. If so, then immediately mark it as 90 degrees. Theorem 4. Opposite angles of a cyclic quadrilateral are supplementary. That means cyclic quadrilateral. Cyclic quadrilateral means we have a circle where the four vertices of the quadrilateral are on the circle. That means they are present on the circumference of the circle. So if the quadrilateral is cyclic, then the opposite angles are going to be a sum of 180 degrees. So you could also say opposite angles of a cyclic quadrilateral add up to 180 degrees. Now over here we have a quadrilateral which is on the circle. Its four vertices are on the circle. So this angle and this angle, say for example if this is A and this is B, then angle A plus angle B is going to be 180 degree. If this is my complete angle, say C, and this is my complete angle D, then angle C plus angle D is going to equal to 180 degree. If I add these two, I get 360 degrees. So the sum of angles of a quadrilateral, they add up to 360. If I have an angle that is at the center, then this will not be considered. Why? Because it is not on the circumference, it is on the center. So this won't be considered as a cyclic quadrilateral. So if I have, for example, if this is P, Q, R, S, then quadrilateral P, Q, R, S is a cyclic quadrilateral, whereas quadrilateral P, Q, R, O is not a cyclic quadrilateral. Alternate segment theorem states that the exterior angle of a cyclic quadrilateral or a triangle is equal to the opposite interior angle. So over here it is very important that the quadrilateral or the triangle to be cyclic, having an exterior angle, then this exterior angle will be equal to the opposite interior angle. So if I have a quadrilateral that is cyclic, then the exterior angle X will be equal to the opposite interior angle. So you will see the angle that is formed with this. So the opposite X will be equal to the exterior angle. Similarly, if it's a triangle, then the exterior angle will be equal to the opposite interior angle. So over here in a triangle, how do we remember the chord and the tangent that are making the exterior angle? See to that chord, the angle that is opposite to that chord will be equal to the exterior angle. So don't get confused, just see the chord and the tangent and the angle that is opposite to the chord that is forming the exterior angle will be equal to the exterior angle. Similarly over here you have an exterior angle, the chord that is forming this angle opposite to it, that angle will be equal to the exterior angle. Theorem 6. The tangent at any point of a circle and the radius through the point are perpendicular to each other. What is a tangent? A tangent is a line outside the circle where it touches the circle at the circumference only once. Now we can see over here there is this line T, which is a tangent. Why? Because it is touching the circumference of the circle only once. So if you draw a radius and a tangent, then the point where they meet is 90 degree. If I have another point, say for example I have another radius, say OR, and this is OA. So this OR is a radius, but it is not touching a tangent. That's why it is not going to be 90 degrees. So we come to know that if I have a radius and a tangent and they both intersect each other, then the angle that is formed is going to be 90 degree. That means radius is always perpendicular to the tangent. Theorem 7 states that if there are two circles that touch each other, then the point of contact lies on a straight line joining their centers. So here I have circle 1 and circle 2. The point where they touch, let it be T. So the point where they touch will be on a straight line joining their centers. So we come to know that O, T, C are collinear points, where O is the center of circle 1 and C is the center of circle 2. T is the point where the two circles are touching each other. Similarly over here we can see O is the center of circle 1, C is the center of circle 2. They both are meeting at point T, and here also we can see that all the 3 points are collinear points, or you could say that they all 3 lie on a straight line. Theorem 8. The two tangents drawn from an external point to the circle are equal in length. So if we have a circle and we have two tangents of the same circle and they meet at a point outside the circle, then these two tangents are said to be equal. So we get AT, segment AT is equal to BT. Over here we get to know that this is a radius and this is a tangent, so this will also become 90 degree. This will also become 90 degree. So whenever you have a diagram, a circle, and you have a point outside, so search for two tangents such that they meet at the point that is outside the circle. If it is so, then immediately you mark them, show this is 90 degree. So even if you miss out somewhere, you may get marks for just showing these 90 degrees. The chords in a circle are equidistant from the center of the circle, then we say that they are of equal length. So if I have two chords, say A, B, C, D, if their distance are same, then we can say that chord AB is equal to chord CD. Vice versa, if chord AB is equal to CD, then OX is equals to OY. So these kind of sums usually they appear. So whenever you have chords, search for the distance between the chord and the center. If they say that the chords are equal, then this distance will also be equal. If the distances are equal, then the chords are going to be equal. The last theorem, chord in a circle is perpendicular bisector to the radius of the circle. So if this is my radius, say OR, this is my chord AB, then my radius is perpendicular to the chord and also it bisects the chord. That means AX is equal to XB and OR, that is my radius, is perpendicular to the chord AB. Stretch yourself. Now let's start with the exercises. I hope you all remember all the theorems. If you don't remember any theorems, let's have a quick review of the theorem. Theorem 1. If you have an angle at the center and an angle on the circumference with a common arc, then if this is x, this is going to be 2x. Common arc, two angles on the circumference, then they are going to be same. An angle on the circumference which has a diameter, the longest length you could say of the triangle, or diameter, and the angle opposite to it which is on the circumference is going to be 90 degrees. Here we have a cyclic quadrilateral. Opposite angles sum up to 180 degrees. Alternate segment theorem. External angle, exterior angle is equal to the opposite interior angle. Radius is perpendicular to the tangent. The point where the two circles meet that point is collinear to the center of the circles. Then there are two tangents which are part of a circle, a common same circle. Then if they meet outside the circle at point T, then the two tangents are said to be equal. If the distance between the chord and the center is equal, then the chords are said to be equal, or vice versa. And we know that the chord and the radius are perpendicular bisectors of. Okay, so let's start with the first question. In a circle with center O, AT and BT are tangents. If angle T is 70 degree, find the angle AOB, APB, AQB and TAB, this angle. From the diagram we can see that there are two tangents of a circle which are meeting at T. So we come to know that TA is equal to TB. Then OA and OB are radius, they are meeting at a tangent, so this will become perpendicular. Okay, now if we see over here, let's start step 1. Okay, step 1, in quadrilateral AOPT, right, angle OAT is equal to angle OBT. You have to write the reason, you have to give the specify the theorems. What is the theorem? That radius is perpendicular to the tangent. So we got this. This is how much? This is 90 degree. So angle AOB is equal to 360 minus 90 minus 90 minus 70. So 360 quadrilateral, 360 minus 90, 90 and 70. This gives me 120. 110. So I came to know that this is 110. Now we can see over here, step 2, we have circle. This is what we found out, that was 110 degree, and also we have P over here, which is on the circumference and which is having the common arc as 110. So over here we come to know which theorem are we going to use. We are going to use this theorem 1, where if you have it in the center, 2x, and this is going to be x. So step 2, we are going to use theorem 1. So angle APB is equals to half of angle AOB. What are we going to write over here? Angle at the center is twice the angle at the circumference. So angle APB is equals to 1 upon 2 multiplied by 110. 1s are 2, 5s are 10, 2 5s are 10. So we get it 55 degrees. So we got angle AOB, we got angle APB, that is 55 degrees. Now let's find, if you look over here, PAQB, it's a quadrilateral, cyclic quadrilateral, since PAQB, these vertices are on the circumference. So step 3, quadrilateral APBQ is a cyclic quadrilateral. Therefore angle APB plus angle AQB is equals to 180 degrees. What are we going to write? Sum of opposite angles of a cyclic quadrilateral is 180 degrees. So therefore angle AQB is equals to 180 minus 55, which gives me 125 degrees. Now we got this as 125 degrees. Now what is left is TAB. This is also found out. TAB. Now to find out TAB, we know that, so we got this angle as 110. This was 55 degrees, 90, 90, and this was 125 degrees. This is equal to this. Now step 4, if you look over here, this is T, that is 70 degree. This side is equal to this side, A, B, because we know TA and BT are tangents. we have to find out this angle. Now we can see over here triangle ABT is an isosceles triangle, right? Why? Reason? Because tangents AT and BT are equal as they meet at a point outside the circle. Fine. Now let this be x, this will also be x, base angles. So angle TAB plus angle ATB plus angle ABT is equals to 180 degree. That is sum of angles in a triangle is 180 degrees. So TAB is x plus ATB is 70 plus x is equals to 180. So 2x equals to 180 minus 70. X is equals to 110 upon 2, which gives me 55 degrees. Therefore, angle TAB is equals to 55 degrees. Question 2. Calculate the value of x, y and z. X, y and z, let's change the color. X is over here, y is over here and z is over here. So if you look over here, BC is a diameter, ABC is a cyclic triangle, so this will become 90. Then if ABC is a cyclic triangle and this is a tangent TA, then this angle will be equal to this angle by alternate segment theorem. Then we know this will be equal to this because these are the two tangents of a circle which meet at a point T outside. If these two are equal, then this is equal to this. This is also be x. Okay, so we got z over here 24. So 24, 90 will give us this 180 degrees. Okay, so let's start. We got the solution. If anything required, we can have it over here. So we'll be using theorem 8, theorem 6 and theorem 3 over here, and theorem 5 not to forget. Okay, so let's start. Step 1. Step 1, angle DAC is equal to angle ABO, which is equals to 24 degree. So that is equals to Z. Why? From alternate segment theorem. Step 2, Step 2 over here, straight line. Step 2 we will write this angle CAB is equals to 90 degree. Why? Because angle in a semicircle is 90 degree. Okay, so we got this as 90. Step 3, angle TAB plus angle BAC plus angle CAD is equals to 180. Linear pair property. That means if you have a straight line, then the angles that form the straight line add up to 180. So angle TAB, for example, X plus this is BAC is 90 plus CAD is 24 equals to 180 degree. So X is equals to 180 minus 9, 10, 11, 4, which is equals to how much is this? 166. This becomes 7, 7 minus 1, 6, 66. Step 4, angle TAB is equal to angle TBA, which is equals to X is equals to 66 degrees, because these are the base angles of an isosceles triangle TBA. How did you get it as an isosceles triangle? Because tangent TA is equal to tangent TB. What is it? Tangents of a circle are equal when they meet at a point outside the circle. It's very important to write the reasoning, because they always ask you to write the reasoning. So we got X as 66, Z as 24. Now on basis of this we can find out Y. So it's going to be angle TAB plus angle TBA plus angle BTA equals to 180 degree. Sum of angles of triangle is 180 degrees. So now Y is equal to 180 minus 66 minus 66, which gives me 48 degrees. So I get Z 24, Y 48 and X 66. Question number 3. In the circle with center O, angle AOB is 70 degrees, BEC is 50 degrees. Find angle AEB. So this angle is what we have to find out. Okay, then angle D and angle DAE. That means we have to find out this angle. Now if you look at the diagram, let me change the color. We can see this is the diameter. This cannot be 90 because it is not over here, cyclic. Then what else do we have? These are equal? No, because they don't have a same common chord. Neither these two are tangents, and this is not the outer one. We can come to know that this are radii, so they are going to be equal. This angle and here we can see that BE is also a diameter, C is on the circumference, so we have this 90 degree, right? Angle on a circumference of a semicircle is this is 90. If this is 90, so here we got this 90, then this is 70, so okay, fine, 90, 50, we'll get this angle. This is a straight line. If this is 70, then this will become 110, this will also become 110, and this triangle we can then find out this, and away in this triangle we can find out this. So let's start. So here we are going to use this theorem 3. We're going to use theorem 3 over here. Step 1, angle BCE is equals to 90 degree. Why? Because angle on the circle in a semicircle. Step 2, in triangle BCE, angle EBC is equals to 180 degree minus 50 minus 90. Why? Sum of angles of triangle is 180 degree. So angle EBC is equal to 40 degrees. Okay, now step 3. So we got this as 40 degrees. Okay, now we can use angle AOB plus angle BOD is equals to 180 degree. Linear pair property. So we get angle BOD is equals to 180 minus 70, that is 110 degrees. Step 4, in triangle BOD, okay, angle BDO is equals to 180 minus 40 minus 110. Again over here we'll write sum of angles of triangle is 180 degrees. So angle BDO is equals to 180 minus 110 minus 40 gives me 30 degrees. So my angle D is equals to 30 degrees. Now we can write step 5, angle BOD is equal to angle AOE vertically opposite angles. Now we know triangle AOE is an isosceles triangle. Why? Because AO is equals to OE, they are radii. So therefore angle AOE plus angle, let this be as X, plus angle AEO plus OAE is equals to 180. Again sum of angles of triangle is 180 degree. So we get 110 plus 2x equals to 180, 2x equals to 180 minus 110, 2x equals to 70, x is equals to 70 upon 2, 2 1s are 2 2s are 2 3s are 6, 5s are. Therefore angle AEB is equals to 35 degrees. This is 35 degrees. So finally we used one theorem, an important one. On basis of this we were able to find out EBC, we were able to find out D, EAE, EAB, sorry, and DAE. DAE will be equal to this, so angle DAE is equal to 35 degrees. Since these both are equal, base angles of a, these are the base angles. X is the base angle of isosceles triangle. This question is from past paper, Cambridge IGCSE, paper 2, February March 2023. Here we have a circle which has ABCD, a cyclic quadrilateral, ABX is a straight line, and PQ is a tangent to the circle at point A. Angle CBX is 85, angle BAQ is 55, and angle CAD is 42. So we have to find out angle CBD. This angle is what we have to find out. CBD. Now we can see over here CBD and DAC, they share a common arc. Therefore, this angle will be equal to this angle, so this becomes 42 degrees. So this angle is equals to angle CAD, which is equals to 42 degrees. What is the reason over here? Angles on a circle with same arc are equal. Angle ACB. Angle ACB. Now this is a cyclic triangle. Okay, 55. This will become 55 degrees. Is equal to angle BAQ, which is equals to 55 degrees. This is a cyclic triangle, so alternate segment. Alternate segment theorem. Then ADC. Again, ADC is a part of a cyclic quadrilateral which has an exterior angle. So this will become equal to angle CBX, which is equals to 85 degrees. Again, this is alternate segment theorem. Here we had cyclic triangle. Here we have cyclic quadrilateral. Then angle BCD. Angle, this angle BCD. We have to find out this angle. Let me change the color so that it becomes easy for us. We have to find out angle BCD. BCD, this angle, these two add up to 180, but then it's equals to ABX is a straight line, so if you find out this angle, then this angle will be equal to this angle, right? So step 1 is 180 minus 42 minus 85, which gives me 53 degrees. So this becomes 53 degrees. Linear pair property. So angle DBA is equals to angle DCA, which is equals to 53 degrees. Again, angles on a circle with same arcs is equal. So this is what we got. Step 2, now let's add angle BCD is equal to angle DCA plus angle ACB, which is equals to 53 plus 55, which is equals to 108 degree Celsius. Okay, now the last one, that is PAD. This is what we have to find out. Let me change the color so it becomes easy for us. PAD, this is what we have to find out. So we can again see over here, this is a triangle alternate segment theorem. So this also becomes 55. So this is equal to angle ACD, which is equals to 53 degrees Celsius. Sorry, I went into temperature. 53 degrees. Now over here again we have alternate segment theorem. So finally we got 42, 55, 85, 108 and 55. Question, this is also a past paper question of Cambridge, paper 4, Feb March 2022. Here ABC lie on a circle, center O, angle OBA is 52. Find the angle ACB. Now if you observe over here, these two are equal because they are the radii. So this will also become 52 since they are base angles of an isosceles triangle. Now if you observe that this angle and this angle, they share the same arc, right? But one angle is at the center and the other angle is on the circle, right? So when we have something like this, if this is x, this will become 2x, right? We are going to use the property, the theorem. First theorem that we studied. If you have an angle at the center and an angle on the circle and they have a common arc, then if this is x, then this is going to be 2x. So using this property, we will find out the answer. Come on now, quickly do it. It's an easy question. Okay, so first thing what we will do is, in step 1, triangle AOB is isosceles triangle. Why? Because OA, OB are radii. So angle OAB is equal to angle OBA, which is equals to 52 degrees. These are the base angles. Then step 2, angle AOB is equals to 180 degrees minus 52 minus 52, which gives me 76 degrees. Okay, so my AOB is 76 degrees. Step 3. So we know this is 2x, this is x. Now we have to find out x, right? This is 76 degrees. So we'll have to divide 76 degrees by 2 so that we get x. So angle ACB is equal to, because it is going to be half of AOB, so angle AOB divided by 2, which is 76 divided by 2, 2 1s are 2 3s are 6, 2 8s are 16. Therefore angle ACB is equals to 38 degrees. I hope all the theorems are clear. Yes, finally at the last question. This is again a past paper, Cambridge, paper 4 Feb March 2022. Here we have P, Q, R, S, T lie on a circle, WSR is a straight line, and angle WSP is 112 degree. Calculate angle PTR. This is the angle we have to calculate. Now there are two ways of calculating it. Either use alternate segment theorem and find out this angle. Then since PQRT is a cyclic quadrilateral, so you can show that the opposite angles add up to 180 and you can find out this. The second method is where you find out this angle, right? Now this angle that has been formed, right, and this angle, they both have a common arc. So you can use the theorem where two angles, if they lie on the circle with a common arc, then they are equal. So you can use any one of the methods. Let's use this method, the second method that we discussed. That's easy, you don't have to do too many calculations. So over here you have 180 minus 112 degrees will give you angle RSP, which is 68 degrees. So we got this as 68 degrees. So this becomes linear pair property. Fine. Step 2. Angle RSP is equal to PTR, which is equals to 68 degrees. Reason: angles on a circle with same arc are equal. So for the answer over here is 68 degrees. Don't forget to write degrees. Read your questions carefully. Don't panic while solving it. See what all options are available. Get all the theorems in your mind. See where you can apply which theorem. Once you know where to apply the theorems, automatically the logic will come in your mind and you will be able to proceed with your sum carefully without any mistakes. It's very simple. Students usually think circles to be very difficult, but they are actually not difficult. Just remember your theorems, practice questions. See, the diagram may look very difficult, but in reality they are not difficult. They are very simple. They are just a bit tricky. You just have to keep your cool and go step by step you will then will be able to solve it easily. Thank you. All the best for your future.